All right, so now we're talking about the angles formed by the tangents, chords, and segments, or secants, sorry. Tangents, chords, and secants. So our first little part is the measure of an angle formed by a tangent and a chord intersecting at the point of tangency is equal to 1/2 the measure of the intercepted arc. Okay. Sorry, so let's look at this diagram. So in the above diagram, chord RP and tangent SP intersect at point P. So point P is our point of tangency. The angle formed by this intersection is angle SPR. Okay, so therefore the measure of SPR is equal to 1/2 the measure of arc PR. Okay, so here is angle SPR, that one. Now that angle is equal to 1/2 this arc. Okay, so we're going to call this X, I guess. So X, the angle X is equal to 1/2 of the arc of this pink arc right here. Okay. Now, next one. The measure of an angle formed by two chords intersecting within a circle is equal to 1/2 the sum of the measures of the arcs intercepted by the angle and by its vertical angle. Okay, so we are talking about like vertical angles or the vertical partner of the angle. Okay, so this formula is the angle is 1/2 arc plus arc. So essentially it's the average of these two arcs right here. So say for example, so we have chord AB and chord DC, and they intersect at point E. Now if the arc is 40 degrees, arc AC is 40 degrees, and the measure of the arc BD is 75 degrees, then we want to find the measure of AEC. We want to find the measure of BED. We want to find the measure of AED. And we want to find the measure of BEC. Okay. All right, so let's look at this. So let's first start with AEC. Now, this angle and this angle are vertical angles, so they are congruent. Now, just like our formula here, if we want to find angle AEC and its vertical partner, then we want to do the sum of the intercepted arcs. So we want to, and then divide it by 2. So it's this arc plus this arc divided by 2. Okay, so the measure of angle AEC is equal to the measure of arc BD plus the measure of arc AC divided by 2. So arc plus arc divided by 2. So the measure of arc BD is 75. 40 divided by 2. 40 plus 75 is 115. And 115 divided by 2 is 57.5. Okay, so the measure of AEC is 57.5 degrees. Okay, now since BED and AEC are vertical angles, they're congruent. So the measure of angle BED is also 57. 0.5 degrees. Okay, so let's write that in our diagram here. Okay. And we want to find AED. So this is AED. Now AED and BEC, this one and this one, they're vertical angles, so they're also congruent. Okay. Now we need to find that though. Now we don't know the measure of their arcs, but we do know that these two angles are supplementary, right? They add up to 180. They form a straight line. So if we do 180 minus 57.5, it's going to give us the measure of AED, and it's going to give us the measure of BEC. Okay. So let's do 180 minus 57.5, and that's going to give us 122.5. Okay. And now, since BEC and AED are congruent, they're vertical angles, the measure of angle BEC is also 122.5 degrees. Okay, let's go on to the next page. All right, so new theorem. Another theorem. The measure of an angle formed by a tangent and secant, or two secants, or two tangents, so there's three different cases here, intersecting outside the circle is equal to 1/2 the difference of the intercepted arcs. Okay, so this is the measure of the outside angle, that angle P, is equal to 1/2 the big arc minus the little arc. Okay, so this is the first case. So here we have an angle formed by a tangent and a secant intersecting outside the circle. Okay, so let's first name the following parts: tangent, secant, the point at tangency, and blah, blah, blah. All right, so the tangent line is line PS. Our secant is PQ. Remember, our secant intersects the circle twice, so here and here. And the point of tangency is R, so it's where the tangent line intersects the circle or touches the circle. Okay. Now the intercepted arcs formed by the tangent and secant. So there's two of them. One of them is RQ, and the other one is RT. Okay. So to find the measure of angle P, we are going to do 1/2 times the measure of RQ, the measure of this arc here, okay, minus the measure of arc RT, so this arc. Okay, and let's make a note. RQ is the bigger arc and RT is the little arc. Okay, so let's do an example. So we have the measure of RQ is equal to 120 and the measure of RT is equal to 80. So we want to find the measure of angle P. Okay? So we have our diagram. I'm going to just redraw it here. RQT. So RQ is 120. RT is 80. And we want to find the measure of angle P. Okay. So now to find angle P, again, we take 1/2 of RQ, the measure of RQ, minus the measure of RT, arc RT. Okay. So the measure of angle P is equal to 1/2. RQ is 120. This arc here, minus the measure of arc RT. This one, minus 80. Okay. So 120 minus 80 is 40. And then 1/2 of 40 is 20. Okay. So the measure of angle P is equal to 20. All right. So let's do another example. So if the measure of angle P is equal to 24 and the measure of arc RQ is equal to 110, we want to find the measure of RT. Okay. So we're going to still use that same formula. So let's draw this diagram. So we're still using this. So P R T Q. Okay, so P is 24, RQ is 110. We want to find the measure of arc RT. Okay. So let's plug in what we know into our formula here. So the measure of angle P is 24, and that's equal to 1/2 the measure of arc RQ, which is 110, minus the measure of arc RT, which is X. Okay. Now, what we are trying to find is the measure of RT. Okay. So let's solve for X. So the first thing we could do, well, there's a couple things we could do. We could either distribute or first divide by 1/2. I'm going to divide by 1/2 first, but you can distribute if you'd like first. So 24 divided by 1/2 is 48. So we're left with 110 minus X. So let's subtract by 110. So we get negative 62 is equal to negative X. Now, to get X by itself, we have to get rid of that negative. So we're going to divide by negative 1. So 62 is equal to X. So our measure of arc RT is equal to 62 degrees. All right, so now let's look at another case. So case 2 is an angle formed by two secants intersecting outside the circle. Okay, so we have secant PS and we have secant PR, and they intersect at point P outside the circle. All right, so the same formula still applies. So the measure of angle P is equal to 1/2 times the measure of arc RS minus the measure of the arc TQ. Okay, so angle P is equal to this arc minus this arc times 1/2. Okay, so angle is equal to 1/2 arc minus arc. All right. So let's go to the next page and we're going to do an example of this. All right, so now we first need to name the two secants in the diagram above. So I believe I just said that and told you guys. So one secant is PR and the other secant is PS. Okay, so now we want to name the two intercepted arcs formed by the intersecting secants. So one of them is, remember, the intersected arcs is the arcs in between. So this is one, and this is one. Okay, so we have arc RS and arc QT. Okay. So we want to consider the following. So if the measure of arc RS is equal to 105 and the measure of arc TQ is equal to 70, we want to find the measure of angle P. Okay. So we're still using that angle is equal to 1/2 arc minus arc. Okay. So we're finding the measure of angle P. Now RS is 105. TQ is 70. Okay. So the measure of angle P is equal to 1/2 times 105, the measure of arc RS, minus the measure of arc TQ, which is 70. All right? So let's simplify. So 105 minus 70 is 35. And half of 35 is 17.5. Okay. So the measure of angle P is 17.5 degrees. Okay. Now, before we move on to the next example, one thing I do want to mention is that the closer the vertex is to the circle, the bigger the angle is going to get. Okay, so if I had an AC can, let's just say like that and like that, the angle, so, is going to be bigger. So I lied. The closer the vertex point is to the circle, the bigger the angle is going to be. Okay. All right, so let's look at case 3. So the case 3 is an angle formed by two tangents intersecting outside the chord. Intersecting outside the circle. Okay. So it says, note that the intercepted arcs are a major and minor arc having the same common endpoints. Okay. So these are our points of tangency because we have two tangents. They're going to ask us all this. So we already said name the points of tangency. So one point of tangency is R, the other is Q. Now, the two tangents in the above diagram are PS and PU. Name the two tangent segments. So the segments, remember, tangent segments are just parts of the tangent line where the endpoint is, one of the endpoints is the point of tangency. Okay, so one tangent segment is PR and the other tangent segment is PQ. All right. So again, when we have two tangents, the same formula is going to apply here too. The measure of that angle is equal to 1/2 times the measure of one arc minus the measure of the other arc. Okay. So now we want to consider the following. If the measure of angle P is 90, we want to find the measure of angle QR. Okay. Now here's something that's different about this versus the other ones. Let's just take a look and think about this for a second. These are two intercepted arcs right here, right? QT and RS. But do you guys see how they're still like parts of the circle? There's still two arcs that aren't included within that angle that aren't intercepted. But do you see here, when you have two tangents, all of the circle is being like intercepted. It's in between those two rays that form the angle. Okay. So keep that in mind while I do this, while we think about this for a second. So we are given the measure of angle P is 90. So this is 90. Okay. Now we want to find the measure of QR. Okay. And like I said, we're still going to use this formula, the same formula. But here's the thing. In order to use this formula, we need to know the value of arc RTQ. Okay. We need to know this. But since, like I said, all of the circle is being included in between these two rays, the measure of arc RTQ is going to be equal to 360 minus this, the measure of this, okay? Minus the measure of this arc, okay? So now let's set up this equation and let's solve for the measure of RQ, okay? So the measure of angle P is 90, so we're going to set this equal to 90. Now we're going to do 1/2 times 360, the measure of arc RTQ, which is 360 minus x, the measure of QR. Okay, so now we need to solve for x. Okay, so we have 360 minus 2x. Now I want to distribute this 1/2 here. So I get 90 is equal to 1/2 of 360 is 180. And 1/2 of negative 2x is just negative x. Okay, and I'm going to subtract 180. So I get negative 90. Okay. Negative 1 divided by negative 1, so x is equal to 90. So the measure of arc QR, that's the way they written it. That's the way it's written, sorry, is 90 degrees. Okay, so that is actually lesson 5. Before I end the video, I'm going to put up some more rules that I want you guys to fill in. I'm going to leave it up for a couple seconds, and so you can pause the video and write them in. There's 3 on the front that you guys need to write, and then I'm going to flip to the back, and then because there's another one. Okay, so write the first 3 on the front, pause the video, and then I will flip to the back, and you guys can write down the one on the back. Okay, so here are the first 3. So these 3. So I'm going to let you pause it. Okay, and then I want you to write this one. Okay, so I'll leave the video for a second, and then so you can pause it, and then we'll be all set.